Hello and welcome to week 2 of data mining for managers. In this video, I'm going to go through a few problems from chapter 2 and make sure that you understand what some of these key concepts are. So you can either follow along in your textbook or just watch the video. I'll pull up the questions and go from there. So question 2.1, assuming that the data mining techniques are to be used in the following cases, identify whether the task required is supervised or unsupervised learning. Remember, the difference between supervised and unsupervised learning is whether or not there is something that's being predicted that has a specific target value that we are trying to predict. So question A, deciding whether to issue a loan to an applicant based on demographic and financial data with reference to a database of similar data prior customers. This would be an example of supervised learning, since there's a large database that a company has that tells them information about the customers and whether or not they defaulted on a loan. That is relevant information that the company will use to try and predict whether additional applicants will default on a loan, and they will make a decision then to grant that loan or not. Question B, in an online bookstore, making recommendations to customers concerning additional items to buy based on the buying patterns in prior transactions. This is actually something done quite often on the internet with Pandora or Amazon. They look at things that you purchased and then make recommendations. And this really is an unsupervised learning technique, because they're not necessarily trying to predict that you'll buy something, but trying to group the variables or the items into different classifications. Question C, identifying a network data packet as dangerous based on comparison to other packets whose threat status is known. So they'll look at packets as they come in, compare them to other packets that either are dangerous or not dangerous, and then make a prediction. And so this is supervised learning. Question D, identifying segments of similar customers. This is an example of unsupervised learning, because there's nothing that's being predicted here. All we're trying to do is find things that are similar to each other. Question E, predicting whether a company will go bankrupt based on comparing its financial data to those of similar bankrupt and non-bankrupt firms. So in this question, we have to ask if there's something that we're trying to predict, and the answer is yes, there is, and that is whether a company will go bankrupt. And so this is an example of supervised learning. Question F, estimating the repair time required for an aircraft based on a trouble ticket. And this is an example of supervised learning, again, because the company probably has a large database that has information about aircrafts and repair times on those aircrafts. Question G, automated sorting of mailing by zip code scanning. This is another example of supervised learning, and this is because the machine that scans the mail and sorts that may be right, may be wrong, and so we're interested in the probability of it doing the assignment correctly. Question H, printing of custom discount coupons at the conclusion of a grocery store checkout based on what you just bought and what others have bought previously. This is another example of unsupervised learning, and this is maybe something that could be used in the future to turn into a supervised learning study, but in this setting, this is unsupervised because we're not necessarily trying to predict what people are going to purchase in the future. Instead, what's going on is the grouping or the classification of the customer's purchases. Now we're going to look at question 2.3. Consider the sample from a database of credit applicants. Comment on the likelihood that it was randomly sampled and whether it's likely to be useful as a sample. So if we look down here, the relevant variable that will tell us the answer to this question is the observation number, which if we look here, we got 1, 8, 16, 24, and there's a clear pattern that every 8th observation was selected, starting with the very first one. There are types of sampling that have this look to it. Generally, you would randomly sample one of the first 8 and then take a step sample based on that first one. So the fact that we're looking at the very first observation and then the 8th, that leads me to think this is highly suspect as being a random sample. Certainly it's not a simple random sample. So our next step would be to get a better sample, a different sample. 2.6, in fitting a model to classify prospects as purchasers or non-purchasers, a certain company drew the training data from internal data that included demographic and purchase information. Future data to be classified will be listed, lists purchased from other sources with demographic but not purchase data included. It was found that refund issued was a useful predictor in the training data. Why is this not an appropriate variable to include in the model? So what's going on here is the company is trying to predict purchasers, people that purchase versus they don't purchase. And refund issue presupposes that something's happened, and that is that someone has made a purchase. So if you're going to use refund issued as a predictor variable, that's not going to be very useful, and going into the validation data set is not going to give us any sort of defining information. Okay, finally, let's look at problem 2.7. The data set has 1,000 records and 50 variables with 5% of the values missing, spread randomly throughout the records and variables. An analyst decides to remove records that have missing values. About how many records would you expect to be removed? This is actually a very interesting question, and if you guess at this, which maybe this analyst would be doing, you're probably going to have a lot of missing data. So just to be clear, there are 50 variables in every record, and there's 5% with a missing value. So what that means is in the 50 variables, 5% of those 50 variables are going to have a missing value for any given record. You could think of it that way. And if you do that, then it's not too difficult to see what the implications of that are. So let's look at this question in a little bit more detail. And if we note that for any of the records, the probability that there is missing data, so the probability of missing data is, well, there's lots of ways this can happen, so we want to actually think of it in terms of the complement. So we want 1 minus the probability of no missing data. And so what's the probability of no missing data for any particular record? That's going to be 1 minus, well, we know that there's 5% chance of a missing record for any of the records, and so we have a 95% chance that each of the 50 records are not missing. So 95% for each one. That means we're going to raise that to the 50th power. And when we do that, we get 1 minus 0.077. And if we subtract 1 from 1, 0.077, we get 0.923. In other words, this is saying that the probability of any row having a missing data point, at least one missing data point, is 92.3%. So we can expect then to throw away 92.3% of 1,000 records, so 1,000 times 0.923, and that's 923 of our data points. Now, does that mean that we'll throw away exactly 923? No, but if we were to do this over and over and over again, on average we would throw away 923 observations from from a data set that has 5% missing data. And so you have to be very careful when it comes to throwing out missing data. And we talked a little bit last week about other things that you could do, imputation and estimation and those sorts of things. And this is a very good reason that you want to consider those things. So that's all I've got for this video. We will see you in the next video.